everyone, welcome back to another video, and in this video we are going to study about solving simultaneous equations graphically. So in this type of questions you have to plot two straight lines on the graph, and then the intersection point of those two lines will be your solution. Then you have to look for the coordinates of both the points, right? So the first step will be to plot the lines, and then the second step you have to find the intersection point of both these lines. So our first question is y is equal to 3x minus 1. So in this equation 3x, so our m is equal to 3. So our gradient is 3. The slope of the line is 3. And our c is equal to minus 1. So the standard general equation of a straight line is y is equal to mx plus c. So c is the point. From at that point the line is crossing y-axis. So now this is our y-axis and this one is our x-axis. So this point in the middle is the 0. So we have to look for where is minus 1. So from this 0 above, this is plus and below this is negative. So negative 1 would be here. So at this point, this line is crossing y-axis at minus 1. And the m is 3. So what does that mean? That means that the change in y-axis or change in x-axis. So that means if it's a 3, there's nothing in denominator. So we just write 1. So now our m is, or the gradient is 3 over 1. That means for every 3 change on the y-axis, the line is changing 1 on the x-axis. So if we start from this point, right, so it moves 3 squares up. 1, 2, 3 squares up, and 1 square on the x-axis. So this will be our next point. From here, we start from the point where it is crossing y-axis, and then we move up 3 and we move right on the x-axis 1. Again, we move up from the same point 3, 1, 2, 3, and on the right on the x-axis 1. This is our next point. And from this point, if we see, then again we have to move the same. 1 on the left side and 3 down. 1, 2, 3. This is our next point. And then 1 towards the left and 3 will go out of this line. So, and then we have to just match these points. So this is our first equation, y is equal to 3x minus 1. And the second equation is y is equal to 2x. So we'll try to plot that with a different color. Let's plot it with a green color. So in this one, if we look at this situation, there is no c. So just y is equal to 2x. So here the m is equal to 2 and c is equal to 0. So there is no c. That means that the line is not like crossing at other place. When the c is 0, that means the line is crossing at 0. So this is the point where the 0 is there for both y and x-axis. So that means that the line is crossing the 0 and the gradient is 2. So for every 2 changing on the y-axis, on the x-axis it is changing 1. So let's move from here 1, 2 on the y-axis and it's moving to x-axis. So this is our second point, the same way from where the red line has already crossed. And then again from this point, if we count 1, 2 up and here, this is our second point, then 1, 2 up and this is our third point. And if we go down from here, 1 towards left and 1, 2 down here, and then again 1 towards left and 1, 2 down here. And then we try to plot these lines together. This green line is our second line and its equation is y is equal to 2x. Now we see the point of intersection is this one where the red line and uh, both green line cross each other. So we have to find the coordinates of this point. The coordinates on the x-axis it's 1, on the y-axis 1, 2. So we can write the point of intersection is, first we have to write x 1 and on the y-axis it's 2. So the x is equal to 1 and y is equal to 2. So this is going to be our answer for this question. Now let's see if we can solve any other question which is a little more complicated. Okay, so now let's draw one more equation, and in this equation we can see the y is not a subject. So let's make in this equation 2x minus 3y is equal to 6. Let's make y as a subject. Then let's take y to other side of the equation and this 6 to this side of the equation and take y to other side of the equation, and that will make 2x minus 6 is equal to 3y, and then y is equal to 2 by 3x minus 6 over 3. 6 over 3 will give us 2, negative 2. So this is our green equation. So we'll plot a green line based on this one. So the m is 2 over 3 and c is equal to negative 2. So that means the c or y-intercept is negative 2. That means the line is crossing at negative 2. So here is 0, 1, 2. At this point, the line is crossing y-axis and its gradient or change in y over change in x is 2 over 3. That means for every change on the y-axis 2 points, on the x-axis it's changing 3. From this point of intersection, if we measure 1, 2 on the y-axis up, 3 on the x-axis, 1, 2, 3. So this is our 1 point, and then again 1, 2 up, 1, 2, 3. This is our next point. And from here we go 1, 2, 3 on the x-axis and 1, 2 on the y-axis. So we just plot a straight line like this. So this is our green equation, green line, and then let's change the color for the second one. We again make y as a subject and take this x other side of the equation. So 3y is equal to negative x plus 3, and then we take this 3 to other side of the equation, where 3 is multiplying with y. When it go to other side of the equation, it will divide. So our final equation is y is equal to negative 1 over 3 x plus 3 over 3 will give us 1. So now for the next equation of this red one, our m is equal to negative 1 over 3 and c is equal to positive 1. That means this line of equation is the line is crossing y-axis at positive 1. So this is a positive 1, and the gradient shows that change in y over change in x is this is a negative gradient. So if it's a negative gradient, that means the y-axis, the line will drop. It will not increase on the y-axis. So from here, rather going up, 1 will go down. 1 down, and 3 on the x-axis towards positive side, because 3 is positive. So 1 2 3, right? So it comes to the same point, this point. Okay, so this is our next point, and then again 1 down and 3, 1 2 3, this is next point. And from here also 1 2 3 and 1 up, and 1 2 3 and 1 up. So this is our these are our points. So why do we do like this is, you see, at every point the y is dropping 1 down. For example, this is 0, this is 1, this is 2, this is 3, right? So these are the just points, 0 1 2 3 on the y-axis, and on the x-axis this is 0, this is 1 2 3 4 5. So if you observe at every point in this line, when on the y-axis initially it was at 3 here, from 3 it came down to 2, whereas on the x-axis it has gone towards positive side. So it was, this line was negative 1, this line was negative 2, this line was negative 3, this line was negative 4. So you see it was negative 5 and negative 6. On the x-axis it was at negative 6 and it has increased to negative 3. So on the x-axis it has increased, right? Whereas on the y-axis it has decreased. Y-axis it has decreased negative 1, and on the x-axis, if you observe, this line has increased from -6 to -3. So the change over x-axis is +3, +3. In the same way, in this point, if you see, on the y-axis it has decreased from 2 to 1, -1, and on the x-axis it has increased from -3 to 0 here. So this shows that this line is decreasing. So now we have to plot these red, all the red points together, and we see our crossing point is here. And in this crossing point, on the x-axis it's 3, on the y-axis it's 0. So our intersection point here is, first we write x-axis. On the x-axis it's 3, and on the y-axis it's 0, because all the points of y on the x-axis is always 0. So our x is 3 and y is 0. This should be our solution for this question. So thank you very much for watching this video. So these are called simultaneous equations of straight line graphs, in where these 2 points meet each other or intersect each other. That is our solution. So we solved one example here with a positive gradient where both of these lines were positive. Both lines were positive. That means both lines were increasing like this. So the lines which increase on both sides of x and y axis, those are called positive or direct relationship. For example, this is x axis and this is y axis. So here on this side, the x axis increase, and on this side, the y axis increase, like 1 2 3 4, and a line going like this. That means on x and y axis on both sides it increase. So when both sides x and y increase, that is called direct relationship. Direct relationship. Or it's also called positive relationship, between positive relationship between x and y axis. On the other way, a line which is coming like this, so this type of line is called indirect relationship, or it's also called negative. So why it's negative? Because on one side, right, so on the x-axis it is increasing, whereas on the y-axis it's decreasing, as we have seen before. So on every point, if you see on the y-axis, from a high point it's coming to down, whereas on the x-axis this line is increasing. So this kind of relationship, in which at one axis the points decrease and on the other axis the points increase. So this type of relationship is called indirect relationship. So for example,